Okay, class, it's time to do some busy work. I am tired of teaching, so you just sit there, be quiet, and add up the numbers 1 to 100. So, what is the sum of 1 plus 2 plus 3 plus 4 plus plus 98 plus 99 plus 100? Go!
Excuse me, sir?
Yes, young Gauss, what is it?
I have the answer, sir.
Impossible! It took you less than half a minute.
True, but the answer is 5,050.
Yikes! That's true, but how did you get it so fast?
Well, if you write out the sequence in order, 1 plus 2 plus 3 plus plus 98 plus 99 plus 100, and then rewrite it in reverse 100 plus 99 plus 98 plus plus 3 plus 2 plus 1, and then you make pairs, and then we're going to add those pairs. So we have 1 plus 100, which is 101. Then we have 2 plus 99, which is also 101. 3 plus 98 is 101.
Oh, so all the pairs are 101.
So there are 100 pairs from 1 to 100, and that make 101. So we multiply 100 times 101.
Okay, that's where there's the 10,100.
Right. Then we have to divide that by 2, because we have 2 sequences when we were only asked to find 1.
Oh, wow.
And then you get 5,050.
That's impressive. I'm impressed. Nice job, Gauss.
Sir?
Yes?
I noticed another thing.
Really?
Well, this trick works for all arithmetic sequences.
Oh, let's try a different one.
So if you have a sequence, 27 plus 20 plus 13 plus plus negative 22 plus negative 29 plus negative 36, you have to write it in reverse order. Like so. And then we're going to find our pairs. So 27, negative 36, 20, negative 29, 13, negative 22. When we add them, we get negative 9 every time.
So 20 plus negative 29 is negative 9, 13 plus negative 22 is negative 9, and so on.
So we have 10 pairs, and they're all negative 9, so 10 times negative 9 is negative 90.
Yeah, but that's twice the sum.
So negative 90 divided by 2 is negative 45, which is your answer.
Wow, I am impressed. Let's try that for a sequence, an arithmetic sequence in general.
Well, for that, we'd have to start with our seed, A.
Yeah.
And then we'd have to add our seed plus the common difference, D, which would be our next term.
So A plus D, A plus 2D, A plus 3D, A plus 4D, and so on.
Right, and then you have all the way up to A plus n minus 3D, A plus n minus 2D, A plus n minus 1D.
That makes good sense.
So then we write it in reverse order. A plus n minus 1D plus A plus n minus 2D.
Yeah, and A plus n minus 3D, and so on down to A plus 2D, and A plus D, and A.
And then we find our pairs again. The first term in each,
The second term in each,
and the third term in each.
And the fourth term in each, and the fifth term in each, and so on, all the way down to all n terms. Cool.
When we add that, A plus n minus 1 times D, we get 2A plus n minus 1D.
Nice.
Then when we add A plus D plus A plus n minus 2D, we get A plus n minus 1D simplified.
Now wait a minute, let's think about that for a minute. Take your time, and just think it through to make sure you can really see how the D's add up. Where you got D plus n minus 2 will give you n minus 1, and 2 plus n minus 3 will give you n minus 1. Then we'll have 3 plus n minus 4 will give me n minus 1, and so on. Hey, look at this. 2A plus n minus 1D is the same as A plus A times A plus n minus 1D. Hey, that first is the first term plus the last term. In other words, each pair when added is the same thing as the first term plus the last term.
Right. And there are n pairs.
Oh, so that means n times the first term plus the last term will give twice the sum. Then if we want to get the sum itself, we have to cut that in half. So 1/2 of n times a plus n minus 1d is the sum we're looking for. That's really cool. Look at that. Half of the first term plus the last term is just the average of the first term and the last term.
Right.
Cool. So here are a couple for you to try on your own. This is not busy work.